And so today we will learn how to build a this feature for our application, yesterday application. Before that, let's take a 2 minutes to recap. Can anyone explain mongoose to me? What is mongoose and why should we use it? So Dean just asked me, so what is mongoose thing? Okay, DB library for JS. Yes.
Em English is like a word and the simple version to understand better than MongoDB.
Yeah, correct. So hey, let me switch. Okay. Yes. Mongoose also allow us to write queries kind of shorter than using the syntax of MongoDB, right? Because behind the scene, this is gonna translate or convert the JavaScript code into MongoDB queries. So there's a lot of built-in function in Mongoose. For example, you can create custom method. You can, for example, instead of using file one here and update, you can create your custom method. For example, file by email and update, for example. And there's also built-in validations, so you can validate the input before you actually store the data into your database. And today we will learn how to use a validators into our app. Okay, what's REST API then? Mark? I see anyone who's the latest one who chat. I will ask that person. Okay. What's REST API? Certain conditions. Yeah. It's just a way the people write design APIs. Yeah, just conventional way, conventions, rules. Hibernate? What's that? What's Hibernate? Oh, no, I am. Or for Java? Yeah. Okay. What are the two most important thing principle? I mean, of REST API. So what's the most two rules? Most two important rules. Sorry. I don't really remember. What are the rules most important? Yeah. So you say that there are rules for writing REST API. So what are they? So what are the most important one? So take a look at yesterday slides. Why is it 404? Okay. So there's a couple of reasons why rules principle, I would say. First thing first, we need to name the URL logically, meaningfully, so we can separate the API into logical resource. For example, as you can see here, right? So this route, and anything that go behind after it will belong to this this session or this the class or the topic 8.2, for example. So there's a bunch of different pages in there, right? So for example, page 1, page 2, page 16. So all the pages that belong to this class or this topic will go be like after the in the URL, it's gonna go after the the route here. Okay. So for example, now if I expect to see, I want to see 8.3, so I just can just change this and see place one, right? That's logical, and these resources belong to that specific class. Okay. And another one is each request must be stateless. Stateless, like the server should not have to remember the previous request at all. And it's very important. So how do we know which user is sending the request, right? So based on this, so this is the most important principle. The second most important principle has to be stateless, and the server should not remember anything from the revert request. So how does the server know who's asking, who's sending the request? For example, you user A, you are Ting, and the other one is Min. So how does the server knows Min is sending a request, and it's not Ting, or it's not Khoa, or it's not Mark? And today we're gonna learn how to do that using the authentication here. Wait, that's weird. Okay. And the main content today is authentication. What is that? We also learn how to store and use the credentials, for example, the password, tokens, password, and lastly we learn how to protect resources. Right. So, for example, if I'm the product owner, I want to only the student to be able to see this address, this URL. So I need to implement the authentication to this website to protect my resources, right? So we learned how to do these three things today. But first, what's authentication? Well, as you can see here, it's just restricting access to a certain resources, right? And why do we have to do that? It's very important. Every website has some private sessions that we don't want everyone to see. We only want the member to see it, right? Just to protect resources from unauthorized users. So here's an example. We have the user base, right? So that could be injection. Okay, so we have a user base, and user could be guests, the anonymous users. It could be a member for in our website, or it could be the moderators or admins, right? And for example, if you look at an e-commerce website, right? An e-commerce website, everyone should be able to see the products on the products here. Right? So anyone can see the product on the products. But to create or to sell something, Tiki require you to be a seller, right? Not just any normal user. You have to be a seller in order to create products and post the product to the website, for example. So you need to be logged in, and your user state has to be a seller, not just a normal user. Okay. So, and another one is like to place orders, meaning to buy something, you need to log in. For example, here, if I logged out, and I want to buy this raincoat, okay, I want to buy the raincoat. So I had to log in, right? And you can see here, I need to log in order to buy something from them. So That's also you have to be logged in, and the user state can be a normal user, a buyer, for example. So these two type user, you need to authenticate them to know that they are logged in and who they are and what type user they are. And to do that, yeah, we'll get to that later. Um, Using token is kind of like for single page for like a REST API, yeah. But for long before, people kind of like build a whole website without a separate view at all. They use cookies, but we're going to use tokens in this course. So these information will be processed by the server, and then the server will ask the database who that user is, right? Server doesn't know that the users, they only know have the tokens, or you can say some key, some something that from you can know who they are by asking the database, right? You have the key, and kind of like you have the key to unlock the door, but to know who they are, you need to open the door and look at the face of the owner or someone in the house. So kind of like the server here will handle all the requests from the user, but without knowing who they are. And to identify them, you need to communicate with the database to identify the user. And how it works in our application, we will talk more about it later, just a couple of slides later. Another flow. So here is more advanced flow, even though you see it's very short. Right? Here we go. So first, we have a client, which is the user, right? User. Okay. Assume that this user already registered an account here. Right? Assume that they already registered an account in our website. So for every, so if they want to log in, they need to send email and password, for example, send authentication data to server. And then server will communicate with the database to identify that user. And if it's true, if that password and email is correct, the server will send or return a token to the client. So client here could be your React app or the browser. So server will return a token, mark, call it access token, that's correct. So server will return a access token to the client. And then for every subsequent request, the client here will say, use that token to say, okay, that is me, that's it, that's it, Mark, using the tokens. So everyone will have different tokens. Okay. So here we go. The token here, client will save that token somewhere, for example, in your wallet or in your local storage or on your session storage or the browser. And then for every subsequent request, the client here will send that token to the server. For example, if you want to see all the products, or if you want to buy a product, you need to send that token to the server to identify you as, for example, Mark. And how does the server know based on the token? And here's how. All right, wait, we'll talk more about it later. Sorry. So another example. This one is kind of like step by step. So this is the general flow, and this step by step. The client, is this too small? Can you go to the website and take a look at it? Yeah. There's a link. Okay. So the first one, when a user visits our website, for example, dashboard.myapp.com, and user want to log in with his account, he will need to send the username and password, right, to the server here. And then actually there's nothing stored on the server because the server will issue a token and send that token to the clients. And that token is not saved in the database. We'll talk about how it works. So right, so here's the problem. You don't store anything on the database, but how do you know which user that is? So basically, we will send inside a token is that look like this. This is kind of like a token, which is meaningless to human. But when you use a special tool, you will receive a kind of like the data, a specific data from this tokens. So that's how token works. We'll talk about it later. And then we use the token, send it to the client. The server send the token to the client. So that token will have something in there. For example, this user ID is ABC. Yeah, usually we will store username and password on our server. We don't trust any third party. Okay, and then for every subsequent request, the client will use the token to ask for data. So this is step by step, and this is the whole flow, and this is step by step. So we actually, what do we store here? The database will store the username or your email, user email, and password. Right? We need the password to validate the user, whether it is the owner of the account or not. Just like how you log into Google, you need to provide your username and password, right? And Facebook as well. So the database will store username and password, but we never store a raw password. For example, we never store something like this, password like this. Instead, we will encrypt it into something unreadable by human, right? So basically, we will encrypt it into a hash, and then we store the hash in our database. And that encryptions, the process has to be one-way encrypted, meaning we can only convert something like this, password ABC, into special blah blah blah. But we should not be able to convert this string back to ABC. Never. If we are able to do that, the hacker or someone that have access to your database could do that as well. No, no, no. It's a one-way encrypted. So we encrypt ABC to this string. We should not make it like to encrypt this, like convert, revert it back to ABC, right? There's another way to compare. For example, we'll talk about it later, but it should be a one-way encrypted. Yeah, that takes a while. And if it's too long, that's take like much longer. Okay, so here's how it works. You encrypt the password. So I have a raw password as the word password here. I use some special tool to hash it or to encrypt it into this password, this string, special string here. And then I'm gonna save this one in my database. Okay, as you can see here. So here's how I store the password. Where is it? Here we go. So we're gonna store password like this, right? It take a while to hack this, right? And then, so how do we compare the password? How do we validate the password, right? When we already make it into this special string, how do we compare the password when the user log in? So there's another special tool. The user will enter the password when they log in. They will enter the password again, the raw password, and we will hash it again. We hash it again, And as you can see, the second time we hash it, it changed. The string actually changed a little bit. So for example, here you have the AV dollar sign here at the end, but here you have the AC at symbol at the end. A little bit different. But when we use a special tool and we compare these two, this and this, it will return true or false. So if the raw password is the same, it will return true. If it's not, it's different. They are different. It will return false. Yeah. So to hash this, we have a special code, special key, and that key will be kept like carefully inside our database, inside our server. So we have a special key, for example, super secret. That's a special key, and we will not expose this key to anyone. Okay, because using this key, we can encrypt and kind of like, yeah, we can encrypt the password. And it will, and when we use compare, it will always return true. It's very dangerous to, so we never expose this special string. So usually it's going to be that special string is going to be a very long string like this, right? Okay. We will learn how to code, how to use it in our application in the lab. So we talk about how to encrypt and store the password and how to compare the passwords. Then after the user login, as you can see here, here's the flow. After the user login, right? The server will check. After the server, the user submit their username and password, the server will validate that password. And then if it's correct, we will issue the token, right? Issue the token. So what is that token? That token is just a, we're going to use a JWT, JSON Web Token, a JSON Web Token. And what is that? So, so that JWT will comprise of three parts. So you have the header, you have the payload, you have the signature. Oh, this one, you may have this question in your in the interview. So you need to understand what are there inside a JWT. Okay, inside a JSON Web Token, there will be three parts: the headers, which contain the type of the tokens, the algorithm that is used to hash it. Okay, that is used to hash it. The second part is the payload, which is the data, So for example, I will explain it later. And the third part will be the signature. It's kind of like secret key, but it's kind of like the key that is used to encrypt it. So here's, so I explain it more here. JSON JWT IO. So so for example, here's an example of a JWT. And there will be three parts: the header, the payload, and the signature. So the header will contain the algorithm and the type of the token. So right now it's a JWT. The type is to use the algorithm to use that is used to encode it is the HS256. Okay, the payload is whatever we want. When we issue the token, we can design the payload. Okay. So right now the payload is I don't know what sub here is, but name is the genre, very common name, for example. Okay, IAT is like issue at. Okay, issue at. You also have you may have another field like at. I don't remember some, but something like that, meaning expire at some time, for example, like that. So you have the time that it token is issued and the expiration. The third part is the verify signature, which is the secret key that is used to verify the token. So when I say verify or verification, it means three parts. Okay, verify a JWT will comprise of three parts. First is decode the token. So when you decode it, you will see something like this and this. Okay. The second is you actually there are only two. The second part is to use the secret key. Sorry. To validate token, as well as to check the expiry or expiration time and expiration. Okay. So I'm going to note here. So when we use the method verify, we actually decode it, and we also check is that token really belong to us by using a secret key that I talked about earlier. We also validate the token by checking the expiration day time of that token as well. So when we verify it, we actually perform two tasks here, right? So where am I? So I will show you the npm.js.com JSON web token. Here we go. So this is how we issue a new token, right? The data is going to be our payload. So this is going to be our payload here. And this is the secret key. So right now we name it secret, and this is the option. For example, I want to make this token expires in 30 seconds. So maybe 1 hour. Okay, expire in 1 hour. So you have a expiration at expire at some 1 hour later after this. So this is a Unix timestamp. This is a Unix timestamp. Okay. Where am I? Sorry. So when we verify that token, we actually so this is a function to verify that token. Okay. You also have another function to decode it. Decode here. Wait, where's okay? You also have a function just decode. We actually use Haskell to instance. Yeah. Yeah, that's some type of type authentication as well. So I said before, like we want to verify a token, right? So and verification means we perform two tasks: decode, and then checking the token whether it's expired or not, or whether it belongs to us or not. And we include the decode here. You can just simply decode it, but you're not sure that if that token is yours and that token is expired or not. Okay. So when we decode, we actually just have this information only. So, and here's how we verify it. Verify. Here we go. We verify the token. Okay. So this is the token, the JWT token that we receive from the client. And then this is the secret key. and then whatever we want to do with that token later after we verify. Or you can use async and await. So that this is a callback, or you can use async and await. I will show you later. I will show you later in the code. So that's it for JWT. And next, there's a reason why we use JWT instead of just a hash or any special technique, because JWT is very lightweight, compact, lightweight, and recent currently is used very widely in many languages and frameworks. For example, you can use it Python, JWT. You have that. Golang, JWT. You also have that. It's everywhere. Every language can use JWT. That's why it's famous and it's widely used. It's kind of like one of the safest way to authentication over HTTP request. It's also stateless, right? You don't have to store the data in this token inside your database. Well, actually, there's some case you want to store it, but in common way, you don't need to store the token at all because you already have some data in the payload. But keep in mind that this data is not secret, it's not private, right? Everyone have that token, will see this data, so you should not put any like sensitive data in here. Right? Just the user ID is fine. Don't put the password there, okay? Or anything that's very important, don't put it there. Just the user ID is fine. Okay, it's stateless. You don't need to store the token in your database unless for some special reasons. And when you get advanced to that, we will talk about those special reasons. They actually, it could be your device specific specs. For example, if you want to track who's logging in, you can store the token together with the IP address or the location of that user, for example, something like that. So for special reasons, but normally we don't need to store it. And so we talk about encrypting the password, comparing password. First, we'll talk about the JWT token so that we can use the token to for the client to communicate with the server to authenticate that user or specific user. We also learn, so now we talk about protected routes, protecting resources. So we have a token, right? So when we log in, right now we have the tokens, and from now on, we're going to use that token together with every request, every subsequent request. So here, an example, you actually used that before. Yeah, on week six, so you will put the authentication or access token in the headers, right? So for example here, yeah. So when you log in, where is it? So when you log in, let me test it. Okay. Yeah. Oh, my server is down. Oh my God, no way. Or whatever. Okay. For example, when I log in, I expect to receive a set token. Okay. And then for every subsequent request, for example, if I want to create a new block, I need to provide the token in my headers. Here we go, right? Or you can look at this. My headers, I have this key. Inside that keys, I have the bearer, space, and here's the token. Okay. You should remember this. You just did it like 10 days ago. Maybe. No, someone's logging in my account. Okay. No, someone's logging in. Okay, that's fine. So we use a token for every subsequent request to identify the ourselves. And you probably like there will be like 100 handlers or endpoints, right? So if you want to validate a token in 100 function, it's gonna be too much. You have to repeat the code a lot. And to the solution to for that is that we're gonna use a middleware to authenticate the user, to check whether that user is correct or not, whether that user is the owner of the post or not. So we're going to use a middleware. You already learned that as well, right? So it's going to look like this. If you look at the code, it's going to look like this, middleware called auth. So in order to, can you see this? So in order to update a book, you need a middleware to check whether you are the owner of the book, for the lead as well. Or to create a book, you need to let the user, the server knows who you are, so that when you create a book, the server will like kind of attack the owner of the book, for example, to you, for example, Ting or Mark, and we learn how to do that. We also have to modify our database a little bit, our model a little bit. So today we're gonna implement that authentication to our application. Okay, I've been going too fast, I know. So let's go back from the beginning and briefly talk about each process. So we have 3 processes today. We have to deal with today. First thing first, we need to, I'm gonna open the note here. We need to first register, right? Which means we generate, we encrypt the password. Sorry, this one's too small. I'm gonna open HTML. Okay, so we will do 3 main things today. First, register, meaning we have to encrypt password and store it, save it to database, right? We also, sorry, 1.1a is like we log in, which means we comparing to raw password. Actually, the raw password with the hash password, right? And then we issue JWT tokens, right? Third, we validate, we authenticate, protect, or you can call protect resources by verifying the JWT. Okay, issue token and send it to client. So we learn how to do these three processes: register and then login. After that, we issue the token to clients, then protect the resource by verifying those JWT inside headers. Okay, let's go back. Let's talk about register and login. So can anyone, if you don't have a solid idea or solid understanding about this, you can ask. Okay, so I think I like this slide the most. Okay, client, we send username and password to register, right? But maybe email and password to register. And when the server will hash that password to a hash string, and then server will start hash string in a database. Okay, and then when a client wants to log in, they also need to provide the email and password. Inside the server side, server will check, will use a compare method here like this to compare the raw password with the hash password in database. Okay, and then issue the token. Then send the token to the client. So client here will be our React app or Postman, and client will save the token somewhere, anywhere is fine, as long as the token is saved. And a token will be used for every subsequent request to the server. So here we go. That token is saved in the environment on Postman, and that token will be used, be sent together with every subsequent request. For example, creating a new blog or deleting a blog here. You also need the asset token, right? So every subsequent request need to have the token. So based on that token, the server will know who that user is. For example, it could be Khoa, it could be Ting, it could be Mark. And that's the whole flow. To store the password, we never store the raw password, we store the hash password. And it has to be a one-way encryption, meaning we can only convert a raw password into a hash password. We cannot do the otherwise. Okay. Should not. And here's how it works. Raw password to hash here. We hash it to this string and then store this string in our database. Okay, then we compare. The next time the user wants to log in, we compare the raw password with, no, actually not compare the raw password. We convert a password into another hash, and then we compare the two hash to be precise. So if they match, we return true. Even though you see they are different, right? But that tool, when you use that tool, it will return true or false if the raw password match each other. And then finally, if it match, we issue the token, and that token comprises of three parts. We don't really care about the headers and signature at all. Basically, we only want to care about the payload. And we can customize what's inside the payload. For example, we're gonna store only the ID, the user ID. And then when we receive the token, we can verify the token, we can decode the token so that we can have the user ID, for example. The user ID like this, and then we use ID to find the exact user in our database. Where am I? Sorry. Okay. And that token should not store any password or any sensitive data. Okay, that's okay. Using the token, we verify the token. We use the ID inside the payload to find the exact user in database. Okay. So for example, when I have the token, when I decode the token, I have the user ID. Yeah, the user ID. And this is the user ID. And using this ID, I can find Khoa, exact Khoa. There's only one Khoa with that ID. No one else. and you will never type like never have the same ID. Even if you have so many different databases, the ID will be different. Okay. So do you have any question about the whole flow, authentication flow? The flow is very important. You may forget the how to code. It doesn't really matter to know how to code, but you need to understand the flow. What's happening here? It's very important to understand these slides and this one as well. The way we code could be different from, for example, if we use it framework, it could be different if we use another framework or another language, but the flow could be the same or even more advanced. So there's, as I have here on my slides, oops, it's not updated, sorry guys. Here we go. So, okay, I will answer Jishan. So I have a note here. So what we have done, what we learned just now was just a simplest way to deal with authentication. But in fact, in real application, it's a little bit more complicated than if you want your app to be more secured, we will have to use a more complicated solutions. So that's why we have access token and refresh token. Right? You can learn, you can read more on this topic on Google, but I'll provide you a very simple note, a summary note for the whole process. Let me copy this. So if you want to read more on this, you can read it here. So here's my my note. It's already on Learning Portal. So answer for Jishan, should we save the private key in the backend side or only on the front end? Oh, Jishan, the whole process is on the backend side, and the secret key here, the private key here is we will not push it to GitHub or anywhere else. Instead, we're going to use it as a variable, a global environment variable. So for example, I'm going to have secret equal to some special string like this. Okay. Or just a super secret. That's fine. All right. We should not expose this key to anyone else, and we also not store it on the front end. It should be on the backend side, because any I think you're mistaking private key with a token, right? The private key is something that to encrypt password or to it's not really encrypt, to issue a token or to decode, not really decode, to verify a token, right? To issue a new token, to verify a token, is it's not the token that we send to client and then client send back to us. That token, if it is exposed, is fine. Usually the access token only have like 15-minute expirations. That's how we deal with securities, but let's not worry about it too much in this course. There's a further reading if you want to know more about it. Okay. So basically it's this. Okay. When user log in, we I think I have a sample here. Okay. When the users log in, we issue the token and then we return the token to client. Right? Client will store the token on the local storage. right? Front end, actually front end will store it somewhere, and the token is fine if someone else have it, right? It's fine. It's not the end of the day. So using the token, the client will could be able to let the user, the server knows who they are, who is. For example, using the token, it means that I have this ID. So this is my ID. Use this ID to identify me, to find me in the database. So this is me. So the token will have inside this. I'm going to copy this. Okay. And I go to this website, the JSON web token. I'm going to paste. Now, as you can see here, in the payload, you have the ID. And this ID should be the same here, right? Here we go. Same, same, right? So what does it mean? It means that the payload here is not safe. Anyone have the token can see the data. But when you verify it, you also need to provide your secret key here, right? Secret key. And this one is very important. You this secret key is gonna be this key. Okay, and you will never leak this key to anyone else. You will not push it to GitHub. You will not put it on the front end. You will not put it anywhere inside out your code. Okay, keep it to yourself. And if you want to set it up, you go to Heroku. Go to Heroku, and then, for example, here you set up the var like this. So, for example, secret key, ha 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 ha. Okay, and remember, if you change to a different key, right, all the JSON web token will be invalid. You cannot verify them anymore because you cannot verify the existing JWT because you use a different key now, secret key now. So when you verify them, it's always return false. Okay. Where am I? Okay. Any other questions? Right. If we don't have any question, then let's take 5-minute break, and then we will try to have this filter first, registering. So by when the user register an account, we will encrypt the password and save it to our database. Okay. So you should we will work on the yesterday assignment. Okay. Again, do you have any questions? So the least thing that I expect you guys to understand here is the flow. Okay, the flow here. At least you need to understand this flow, and you can explain it to other people or to your friends. Yeah. It's good if you can explain it to another people or a person. So client, again, last time, client, when a user register an account, they will send the email and password to server. Server will encrypt the password and save it to the database along with the email. Okay. And then next time client, a user want to log in, he also needs to provide the username or email and password to the server. Server will compare, will hash that password again, the new password. It will hash a new password and then compare the two hash strings. If they match, it will turn true, and then if it's true, server will issue a token, a JWT token. Oh, and then on the subsequent request, the client side will use a token to communicate with the server. Okay, that's it. You might only have time to do what you had done with yesterday's assignment, not to do anymore. That's fine. Actually, we only need it could be a separate application today, but I want to connect it with yesterday's assignment so that you can protect a certain resource. Right. Actually, we only need the books, collections, and rounds. As long as you have these, then that's fine. Cool. Okay. If you don't have any question, let's take 5-minute break or more. Come back at 11:15, guys. See you then. Be right back.